Hello and welcome to the Bearded Math Man's YouTube channel. Ladies and gentlemen, I'm very excited about this lesson. It's going to be a two-part lesson. We're going to be talking about imaginary numbers. Yeah, let's get to it, right? Here's what we're going to be doing in these two videos. In the first video, I'm going to teach you what imaginary numbers are, where they come from. In the second part, we're going to teach you how to do arithmetic with imaginary numbers. But in order for us to get number one done well, in order for you to really understand what imaginary numbers are, we need to do a quick refresher on some square roots. So in this video, we're going to teach you how to simplify the square root of a negative number. We're going to teach you what I is, all that kind of happy jazz. We're going to teach you what happens when you're dealing with a quadratic equation and you get something like this. So you see this quadratic equation, 3x squared minus x plus 9. If you're going to find the x-intercepts, not factorable, so you're going to use the quadratic formula, like this right here, right? Now, the radicand of this is negative. And if you remember the thing called the discriminant, right? The b squared minus 4ac part of the quadratic equation, if that's negative, then that means there are no real solutions. It means there's no x-intercepts. And that makes sense because this graph, if you found the vertex, you would find out that the vertex is in the first quadrant, which means it's above the x-axis, and a is positive. So this graph's going up, doesn't cross the x-axis at all anywhere, right? So let's talk about what that means. Let's talk about what the x-axis is, what the y-axis is, what the coordinate plane is, because, well, that's how you're going to figure out how imaginary numbers fit in and don't fit in. So the x-axis, right, that's the input for a function, and you can use any number you can find on the real number line. So the x-axis is just the real number line. So is the y-axis for that matter, right? So that means for an input, you can use any number, any real number you can think of. So a whole number, irrational, you could use pi, square root of 2, you could use 3/8, you could use -7, 0, whatever you want. So you plug that in. Whatever output you get that's a real number gets plotted along this line. This is called the Cartesian coordinate plane, and both x and y are real numbers. And up until now, that's probably all you know about. But there's more. There's a lot more. But before we can get into that, before we can get into how that more works and how we could graph them, we have to see where this comes from, right? It all has to do with the square roots. So let's talk about that real quick, okay? Square roots are numbers. They are numbers with a special property. If you take a square root number and you multiply it by itself, the product is the radicand, right? The radicand is the number on the inside. However, if you take a square root number and you multiply it with a different square root number, what you get is the square root of those radicands multiplied. Do you see? So, for example, square root of 9. If you multiply it by itself, you get 9, right? And so a lot of the time, what ends up happening is you end up saying, well, what squared is 9? Well, 3 squared is 9, right? So if you look at the square root of 9 and you say, hey, what squared is 9? There are actually 3 answers. You guys are pretty good with the positive 3 and the negative 3, but the square root of 9 times the square root of 9 is also 9. So that is actually the reason why the square root of 9 equals 3. It's called the transitive property. You see, the square root of 9 times itself is 9. 3 times itself is 9. That means 3 is the same as the square root of 9. Do you see? Now, typically, you're not taught to think about square roots that way when you're learning how to simplify them. Instead, you're often taught to think, well, what number squared is the radicand? So, for example, if you were asked to simplify the square root of 4, you'd say, well, it's 2 because 2 squared is 4. Square root of 1, that's 1 because 1 squared is 1, right? And here's where we get into trouble. The square root of -1. Well, 1 times 1 is, of course, 1. -1 times -1 is, of course, 1. 1 times -1, well, that equals -1, but the problem is that's not a squared number. 1 and -1 are not the same thing, so this isn't squaring something, right? So there's no real number. There's no number on the number line or the x or y axis that would satisfy this question right here. That's where the number I comes in. The number I squared is equal to -1. So if you take I and you square it, the product is -1. That's why if you say, hey, what squared is -1, it's I, because the square root of -1 times the square root of -1 is -1. I times I is -1. Do you see? Now, let's say you're going to see something like this, the square root of -4. Well, that's imaginary. It's not a real number, right? But we can still simplify it. We can say it's 2i or -2i. And here's how that works. You see, the square root of negative 4, well, that's the same as the square root of 4 times the square root of negative 1. That's what the square root of negative 4 is, right? And the square root of 4 is 2. The square root of negative 1 is I. So what we have, plus or minus 2i. Now, we haven't been doing a whole lot with the plus or minus because at this point, I think you know that they're there. And when something's new, sometimes that extra notation can get overwhelming. But let's move on, shall we? Now, this is a real number line. We usually draw it in horizontal fashion from left to right. So 0's somewhere in the middle. And all of the numbers you know and love can be found on this. So you can find the square root of you can find the square root of anything that's not negative on this number line. Square root of, 0.38, negative 7.2, pi to the power of 48. All of those numbers are on here, right? Well, those imaginary numbers, well, they have a misnomer. Imaginary, like in common English, means made up or does not exist. Whereas in math, it's a little bit of a misnomer. These numbers do exist. The name imaginary comes from back when mathematicians were first learning about these kinds of numbers. They didn't understand them, and they thought that they were just some artificial outcome of doing mathematics. But it turns out they do exist, and some mathematicians didn't like the name imaginary even early on. They thought they should be called lateral numbers because they're to the side of the real number line, right? But I digress. So here's how this works. If you have a real number, like the number 4, you can plot that on your real number line, right? Just like you've always done. Imaginary numbers work the same way. They're ordered from 0 and positive goes up, and from negative infinity, for imaginary numbers up to 0, well, that goes down. Do you see? So 2i would be here, and 4 would be there. Now, this is called the complex number plane. Complex numbers are numbers that have a real part and an imaginary part. So the number 4, that's just a real number, but it can also be written as a complex number because 4 is the same as 4 plus 0i. 0 times anything is 0, right? 0 plus 4 is just 4, right? This is what we call a complex number. It has a real part and an imaginary part. And we typically write the imaginary part second. Do you see? All imaginary numbers can also be written as a complex number. For example, this is 2i, but it's the same as 0 plus 2i. So 0 is the real part, 2i is the imaginary part. And so on the complex number plane, if you had a number that was, say, had a non-zero component that was real and a non-zero component that was imaginary, we can plot those numbers on this plane. So like 4 plus 2i, that would be here in the first quadrant. Now, when we're dealing with polynomial functions, we don't use this complex number plane at all. We use the real number plane, but wanted to share this with you so you can kind of get a glimpse into the future of what's going to happen when you do the square root of, use the quadratic formula, you find that the square root's negative. This is what's going on. This is going to be what we're going to be dealing with in future lessons. So if you would like some more information, I would encourage you to visit my website, thebeardedmathman.com. I will leave a link in the description down below. You can find all kinds of other information and homework questions, practice problems, solutions to those, and also the information on what's coming next. So that was part 1. Stay tuned for part 2 of imaginary numbers. I hope it's been helpful. If it has, hey, give it a thumbs up, share it on social media, and until next time, I hope you have a great day.